Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1-2 for Cambridge AS Physics. In this lesson, as always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS Physics and also you can have better understanding of these questions. Let's study together, let's improve together. In today's class, we are talking about March 2023, paper 1-2, and total time for this exam is 1 hour and 15 minutes, and there are 40 questions on this paper and you need to answer all of them, and the total mark for this paper is 40. If you go to the second page, on the second page you can see values of some important constants. If you need value of any constant for some calculations in your exam, you can come to this page and you can find values of constants. On same page you can also find some basic formulae, and if you have forgotten any formula and you need formula for calculations, you can also come to second page of your exam paper and you can find some basic and important formula. Question number 1 says, what represents a physical quantity? So simply we need to understand what is a physical quantity. A physical quantity should have magnitude. We can simply write down a physical quantity should have magnitude and it should have unit. Magnitude and unit. So if you look at this given options, A is not possible because it has no unit, and B is just a unit, it has no magnitude, and 7.0 Newton, this has magnitude and unit. So the answer for this question is C. D is also not answer because it's just percentage, so D is also not answer. So the answer for this question is C. So you need to understand a physical quantity should have magnitude and also it should have unit. So for this question, answer is C. Question number 2 says the relationship between the variables d and t is given by the equation, by this equation. It is also given to us that b and c are constants and the unit of t is given, that is meter square, and unit of t is second. We need to find out what are the units of b and c. This is a typical question about homogeneous equation. For homogeneous equation, we need to understand each term should have the same unit, and we will be using this concept and we will answer this problem. So we can write down units first of all. The unit of 1 over t is per second, means 1 over second, and we can write down b, and the unit of d is meter square, so we can write down meter square, and there is square root of this one, and here we have c. So this is homogeneous equation, so simply we can say this is per second, then here we have b, so here we will have meter because the power will be cancelled, and the unit of c has to be per second because each term should have the same unit. Now we need to find out unit of b, so we can write down per second. Here we have meter here, so we have to cancel meter, so we should have meter here, and also we have unit, we should have unit per second for this term as well, so we should have per second in numerator, and it is divided by m, so here we have this is per second, so this is the unit of c. Now simply from here you can see this is the unit of b, b has this unit and c has this unit. If you further you want to write down, you can write down this is per second, so meter will be cancelled, so this will be per second, so each term should have the same unit. You can also understand this one with the help of V. This is equal to U plus AT, because sometimes students are not very clear about this one. Always we do the same thing. For homogeneous equation, the unit of V is meter per second. Unit of U is also meter per second. Unit of A is meter per second, meters per second. Unit of time is second. So you can also see from here, each term has the same unit because this is homogeneous equation. Each term should have the same unit. So this is unit of B and this is unit of C. So the answer is not possible. B is right because this is unit of B and this is unit of C. And C is not possible because this is wrong. This is also incorrect. This is incorrect, but this one is correct. And so the answer for this question is B. This is how you can figure out. Question number 3 says a hollow cylinder which is open at both ends has a radius of 3.0 plus minus 0.1 centimeters and a length of 15.0 plus minus 0.1 centimeters. What is the value with its absolute uncertainty of the surface area of the cylinder? We need to calculate surface area of the cylinder, but this is very important one, that this cylinder is open at both ends. Very important point you have to consider when you need to calculate surface area. If cylinder was closed at both ends, surface area will be greater as compared with when cylinder is open at both ends. So in this case, it is given to us, it is open at both ends. So we can simply draw a beautiful cylinder. So this one is a cylinder and it is open at both ends. So this is the cylinder. We can also imagine in this case the radius of the cylinder is capital R, and we can imagine the length of this cylinder, let's say, is equal to capital L. Now we need to calculate surface area. Surface area simply will be equal to 2 pi r, means you will calculate circumference of this circle and you will add all of them for L time. Simply multiply with L. So this is how we can calculate surface area. Now simply we need to plug in values. We have 2 pi and r is given to us, that is equal to 3.0 centimeters, and L is given, that is equal to 15.0 centimeters. Now if we multiply this one, we will get 282.78 centimeter square. So this is value of surface area. Now we need to calculate absolute uncertainty of surface area. So we have delta S divided by S, and this one has to be equal to delta R by R plus delta L by L, because these constants, when quantities are multiplied and divided, they have no role in percentage uncertainty because they will be cancelled. So they have no role in percentage uncertainty. So that's the reason simply we ignore them. So in this case, we can say delta S, this is equal to delta R by capital R, plus we have this is delta L by L multiplied by S. Now simply we need to plug in values. Delta R is equal to 0.1, then R is equal to 3.0, plus we have 0.1 divided by 15.0 multiplied by S. S is equal to 282.78. Now if we solve this one, we will get delta S is equal to 11.3 centimeters square. So this is the absolute uncertainty in surface area. So this is delta S. So we can rewrite here. Delta S in this case is equal to 11.3 centimeters square, and we have calculated value of S. This is value of S. Now we need to write down S plus minus delta S in this form, in surface area with its absolute uncertainty. Now this part is little bit tricky one. You need to understand is that, so here we will have value of S plus minus, we will have absolute uncertainty. Absolute uncertainty, you have to write down up to 1 SF only at AS level. So up to 1 SF, how we can write down this one? Up to 1 SF, we can write down this one is 10. Now this one has, so one thing you need to understand, it should have 1 SF only. You have to follow this rule at AS level, 1 SF. Now the number of dp here, so the second thing, let me use different color, absolute uncertainty and the measurement here, they should have the same number of decimal places. So it means that S should not have any decimal. This is 282.78, so we can write down this one 280. So now this has no number of decimal places, and this also has no decimal places. This has 1 SF and this one has 2 SF. If you look at raw data, this has 2 SF. So it also satisfies this condition, least number of SF in this measurement. So the answer for this question has to be A. So 2 points you need to understand. Same number of dp. First of all, you have to write down absolute uncertainty up to 1 SF only. Then absolute uncertainty and this measurement, they should have the same number of dp. Same dp. So this rule you have to follow. So the answer for this question is A. Question number 4 says a snooker ball of mass 0.20 kgs has a collision so that its direction of movement changes by an angle of 90 degrees as shown in the figure. The ball has a speed of 0.40 meters per second before the collision and a speed of 0.30 meters per second after the collision. we need to find out what is the magnitude of the change in momentum of the snooker ball. So if you look at this ball, it has initial momentum. We can simply write down that is the I, and that is equal to mass of the ball 0.20 times the speed of the ball. So this is the initial momentum. And also we can write down the final momentum for this ball. Mass of the ball is 0.20 and the speed of the ball is 0.30. We need to calculate for this question delta P, and delta P will be equal to P final, means this vector, minus P initial momentum, and this is equal to the change in momentum. We can also write down this one in a little bit different form. We can say P final plus we have negative Pi, so this is P initial. Now simply we need to add these two vectors together and we can find out delta P. So in this case, we have, first of all, this one is P final and this one is P initial, but negative of P initial. So this is to the right. So the negative Pi will be to the left. So this is Pi. And this one is P initial. So you can say this is negative Pi. And we have P final. This is vertically up. So this one is P final. So we can also label this one. This is P final vector. Now we need to find out sum of these two vectors. So simply we need to add. So the sum of these two vectors is equal to this one. And this is delta P. This is delta P. Now we need to find the sum of these two vectors. And the sum of these two vectors is equal to delta P. So we can simply write down delta P because this is a right angle triangle. So simply you can say delta P in this case will be equal to, we are just interested in magnitude. So this is the magnitude. This will be equal to P final square, means the magnitude of P final square, plus magnitude of P initial square. And we have to take the root of this. Now, if we plug in values for P final, we have this is 0.2 times 0.30 square of this one, plus we have 0.20 multiplied by 0.4. This is 0.40. We have to take square of this. And then we take, if we take the square root, our final answer will be equal to 0.10 kgs meter per second. So this is the change in momentum, magnitude of change in momentum, and change of momentum has to be along this line. So this is how we can figure out. So this is, and also the force is along change in momentum. So the force has to be applied in this direction. So this is also direction of resultant force acting on this ball. So the answer for this question is B. Very nice question. So this is how you can figure out. Question number 5 says a ball is kicked upwards at an angle of 45 degrees to the horizontal ground. After a short flight, the ball returns to the ground. It may be assumed that a resistance is negligible. What is never zero during the flight of the ball? So the best way to answer this question is simply we can sketch. So the ball is fired at an angle of 45 degrees. So this angle is about 45 degrees. So this is 45 degrees. So the ball will go first of all up, then this ball will come down. So this is, you can imagine the trajectory of the ball. Now we need to look at first of all acceleration. Acceleration along vertical is equal to g, and direction of acceleration along vertical is always vertically downwards. And if you look at acceleration along x, this one is equal to 0 because there is no force along horizontal. And if you look at horizontal component of velocity, this will always stay constant throughout this journey. So we can say ux is constant because there is no net force acting along horizontal. So ux at this point has also the same value as it has at this point, means the initial value. So if the velocity is v, so the ux will be equal to v. You can say this is also u. So this will be equal to u cosine of 45 degrees. And the magnitude at the peak also will be equal to u cosine of 45 degrees because magnitude will not change. And direction also, it will stay the same. But vertical component of the velocity, this will keep on changing. So this will not be constant. So simply we can say Vy will not be constant. But at this point, Vy, this one will be equal to 0. This will be equal to 0. Question is asking you what is never 0 during the flight of the ball. So in this case, if you look at horizontal component of the ball acceleration, this is 0. This is 0. So it means this one is not possible answer. Horizontal component of the ball velocity never 0. Yes, this is true because this is never 0. It always stay constant. The vertical component of the ball momentum, this will be 0 at the top because V will be 0. So this is also not correct answer. The vertical component of the ball velocity, also 0. So this is also not possible answer. So the answer for this question is B. This is very nice question. You need to understand these basic points about projectile motion. Question number 6 says the graph shows the variation with time t of the displacement s of an object. Which graph represents the variation with time t of the acceleration a of the object? So we have ST graph. So first thing we need to understand what is gradient of ST graph representing. So we can write on gradient of ST graph is representing velocity, or you can say speed, because we are just talking about magnitude. Now if you look at the first part, we can say this is first region, we can say this is the second, and we can say this is third, and we can say this one is the fourth. So you can see in first region, it means from this point to this point, velocity is constant. So there is no change in velocity, and this gradient is positive, so the velocity is positive here. Gradient of this part is negative, so velocity is negative here. Gradient of this part is positive, so velocity is positive, and constant gradient of this part is negative, so it means velocity is also negative. So it means acceleration from here to here, it will be 0. But if you look at this one, when the velocity change from positive to negative, so there is a change in velocity. So there will be acceleration. Positive to negative, it means there will be negative acceleration. And if you look at this one, velocity change from negative means for a very short period of time. Velocity change from negative to positive. So there is a positive acceleration here. So we can say here acceleration will be negative. At this very short period of time, there is a change in velocity. Acceleration will be positive, and here velocity change from positive to negative, so there will be acceleration that is negative. So we have acceleration at this peak, at this peak, at this one, and rest of the time acceleration is equal to 0. So the answer for this question is D, and this is how you can answer. Let me explain you one more point. Delta V, if this is equal to 0, it means A is equal to 0. So in this case, you can see the final velocity is negative. So if we write down A, this is equal to delta V by delta t for a very short period of time. So this velocity is negative minus negative divided by delta t. So in this case, we will get negative. So this will be negative 2v divided by delta t. So acceleration is negative here. Here will be positive, here will be negative. So the answer for this question is D. Little bit tricky question, but if your concept is clear, you can find out. On other hand, this is a nice question to develop your understanding of ST graph, VT graph, and AT graph. Question number 7 says, which expression defines force? So for force, we have to be very clear that when we define force, this is equal to delta P by delta T. So simply it means change in momentum over time taken. So we can say force is equal to change in momentum over time taken. And this force is the resultant force. Change in momentum over time taken. So we can write down here, this is over time taken. Change in momentum over time taken. So very important and basic concept about force you need to understand. Actually, this force is representing the resultant force. So answer in this case has to be equal to D. Every year, in every paper, there will be one question about F is equal to delta P by delta T. Sometimes you need to calculate, sometimes you need to define force. So you have to be very clear about this one and how to use this equation. Question number 8 says, a ship of mass 8.4 times 10 to 7 kgs is approaching a harbor with a speed of 16.4 meters per second. By using reverse thrust, it can maintain a constant total stopping force of 920,000 newtons. We need to find out how long will it take to stop the ship. So you can simply imagine this is the ship. So this is ship. And also we can imagine ship is moving to the right and the initial speed of the ship is given, that is equal to 16.4 meters per second. We can also imagine there is an opposing force that is trying to stop this ship. So this is the opposing force. So F in this case is given. This is equal to 920,000 Newton. And finally this ship stops somewhere here. So the final velocity will be equal to 0. Question is asking us how long it will take. Means the time taken between these two positions. So simply we can say time taken is delta t. So the best way to answer this question is simply we can write down resultant force in this case will be equal to change in momentum over time taken. And in this case we will take to the right is positive. And we need to calculate in this case delta t. So we can rearrange delta t will be equal to delta p divided by f. Delta p. So m times v minus u over f. So we have value of mass. In this case mass is given to us, that is equal to 8.4 times 10 to 7 and v is equal to 0, and u in this case u is to the right, so this is positive, and value of u is 16.4. but force in this case is negative because force is acting to the left, so this is negative, so we have to use negative sign here, so this is negative. Now if we simply solve this one, our final answer will be equal to 25 minutes. So this is the final answer. Up to 2SF, you will get 25 minutes. So this is the time taken to stop this ship. So the answer for this question is C. Question number 9 says the velocity time graphs of 4 different objects are shown. Which graph represents an object falling from rest through a long distance in Earth's atmosphere? So it simply means that ball started from rest and we cannot ignore air resistance. So simply we can imagine we have a ball and the initial velocity of this ball is equal to 0, and in this case air resistance is not negligible because there is Earth atmosphere. So these dots, they are representing atmosphere. So in this case, as the ball will start falling, there will be force acting on the ball in upward direction. This one is air resistance. And the force acting downwards, this is gravity, and gravity will remain constant in this case because gravity does not depend on speed. But air resistance depends on speed, so air resistance will increase. So initially we can say acceleration will be equal to g because acceleration is due to force of gravity, but when ball is moving, acceleration will decrease because F net will decrease. F net will decrease. And finally, these two forces, they will balance each other. So air resistance is acting upwards and the magnitude of air resistance will be equal to magnitude of gravity. When these two forces are balanced, acceleration of this ball will be equal to 0. And so at this instant of time, ball has reached terminal velocity. We also need to understand one more point, then we can answer this question. Gradient of VT graph, you also need to understand gradient of VT graph, this is equal to acceleration. So we can say this is equal to acceleration. Now if you look at given options, if you look at initial velocity, it has 0, so it can be possible answer. This one also can be possible answer. This also can be possible answer, but this is not possible answer because initial velocity is not 0. Now we need to understand as the ball is falling down, speed of the ball is increasing, but acceleration of the ball is decreasing. It means the gradient of the line has to decrease. So if you look at this gradient is constant. So this is telling us that there is no air resistance because A is constant in this case. So A is constant. So we can also write down in this case A is constant. So this is not possible answer. And if you look at this one, the gradient is increasing. So the gradient of this one is increasing. So this is telling us that acceleration is increasing with time, but acceleration is decreasing with time. So this is also not possible answer. Now if you look at this one, gradient is decreasing with time, so it means acceleration is decreasing with time. And finally ball has reached terminal velocity, so acceleration is 0 because the gradient of this line is equal to 0. So it means answer for this question is D. This question is telling us that acceleration is equal to 0. Because the gradient of line is 0, it means acceleration is 0. It means ball is falling with constant velocity. So the answer for this question is D. This is also a typical question. You need to understand these concepts, how to approach this type of problems. Question number 10 says, which statement about collisions is correct? If you look at option A, it is given to us kinetic energy is conserved in all collisions. And this one is incorrect because kinetic energy is only conserved in perfectly elastic collision. Only in perfectly elastic collision. So option A is incorrect. If you look at option B, it is given to us momentum is only conserved in perfectly elastic collision. This is also incorrect because momentum is conserved in elastic and also in inelastic collisions. In inelastic collisions. So option B is also incorrect. For option C, it is given to us the relative speed of approach is equal to relative speed of separation for perfectly elastic collision. This statement is correct. Relative speed of approach is equal to relative speed of separation for elastic collisions. And in elastic collisions, kinetic energy initial is also equal to kinetic energy final. So this statement is correct. If you look at option D, it is given to us when two objects of different masses collide, they exert forces of different magnitudes on each other. The force applied on two objects when they collide does not depend on mass of the objects. So different magnitude, they exert same magnitude of force on each other. So the force applied on two objects when they collide with each other does not depend on mass of the object. So option D is also incorrect. So in this video we have done from question 1 to question 10. I hope you have better understanding of these questions and also you have improved your concepts. If this video was helpful, please like and subscribe the channel because your encouragement is very important. And I'll be uploading videos for remaining questions very soon. And also if you have any question, just leave your question in comments and I'll explain you as soon as possible. Bye for now. See you in next video.
Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1 variant 2. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS physics and also you can have better understanding of these questions. If you really want to improve your understanding of physics, you just need to focus. When you do past paper questions, you need to focus and do past paper questions. So you will understand question in depth and you will solve in a proper way. And also when you listen these videos, you need to focus because when we focus on something, we become part of that. We start feeling that thing. So when you study physics, you focus on physics, you become part of learning physics. Then you start feeling physics. When you start feeling something, it means those informations or those actions you are taking at that time, your brain retain them for a long time. So try to develop this habit and then see the effects on your understanding of physics and also you will see the effects on your life. Let's study together. Let's improve together. Question number 11 says a satellite uses two thrusters to adjust its motion in space. Each thruster exerts a force of 40 newtons on the satellite. The line of action of each force is a perpendicular distance of 2.3 meters from the center of gravity of the satellite. These two parallel forces act in opposite directions. What are the magnitudes of the torque and the resultant force acting on the satellite due to two thrust forces? This question is pretty straightforward one. So in this case, you can see we have one thruster here. It is exerting force of 40 Newton. Another one is also exerting force of 40 Newton, but in opposite direction. And the distance from the center of the satellite is given. So the best way to answer this problem is we can redraw this one. So simply I can redraw this line here. And now we can draw the forces on this one. There is a one force that is acting vertically downwards, and there is an other force that is acting vertically upwards. So this is another force. So in this case we have two forces. So let me redraw this one. So we can redraw this one so it looks proper diagram. So these two forces, they have equal magnitude but they are in opposite directions. So simply I can label this force is 40 newtons and this force is also 40 newtons. And the distance between these two forces is given to us, that is equal to 4.6 meters. 4.6 simply means this is equal to 2.3 plus 2.3. So this is the distance between these two forces. And now if you look at these two forces, they form a couple, and we need to find out torque of a couple, and we need to find out resultant force. So first of all, we can find out F net means the resultant force. So in this case, resultant force is equal to 0 because one force is vertically downwards and one is vertically upwards. So if I take up is positive, for example, in this case up is positive, so this force will be positive, this force will be negative. So now simply we need to add these two forces. So we have plus 40 and we have minus 40 newtons. So the answer will be equal to 0 newtons. So the resultant force in this case is equal to 0. The second thing we need to calculate is torque of a couple. And torque of a couple, simply you need to understand, this is equal to one force time the distance between two forces, perpendicular distance between two forces. And perpendicular distance in this case we can simply say is equal to d. So let's label this one, this is d, and d is the perpendicular distance. In this case, magnitude of one force we have, that is equal to 40, and we have the distance, perpendicular distance between these two forces, that is equal to 4.6 meters. Now if we solve this one up to 2SF, our answer will be equal to 180. Up to 2SF, you will get answer in this case little greater than 180, but if you write down that one up to 2SF, you will get that is 180. So this is 180 Newton meters. So this is up to 2SF because our given data, this has 2SF, this has 2SF. So that's the reason we are using 2SF in our final answer. So the answer for this question has to be C. So this is the answer. Question number 12 says the diagram show two ways of hanging the same picture. In both cases, a string is attached to the same points on the picture and loops symmetrically over a nail in a wall. The forces shown are those that act on the nail. Very important one, on the nail. In diagram 1, the string loop is shorter than in diagram 2, which information about the magnitude of the forces is correct. So we need to compare T1 with T2 and we need to compare R1 with R2. In order to compare these two forces, simply first of all we can resolve T1 into its components, into horizontal and vertical components. So simply we can draw the line here. We can also draw another line here, and the same we can do for T2. So we can resolve into components, vertical and horizontal components. So simply you can first of all complete this triangle. Now in this case you can see it is very clear that this angle, we can say this angle, let's say, is theta 1. So this angle also will be equal to theta 1 because it is symmetrical, and this angle we can say this is theta 2, and this angle also has to be equal to theta 2. Now if we resolve T1 into components, so one component of T1 will be acting vertically downwards and one component will be acting to the left. And if we resolve this T1, one of its component will be acting vertically downwards and one will be acting to the right. So if we resolve vertically, so simply we can say along vertical, r1 in this case, this one has to be equal to 2 times t1. So we can write on t1. So or simply we can say 2 times t1 cosine of theta 1, because this component is with angle. And the same we can do for r2. R2 has to be equal to 2 times t2 cosine of theta 2. Cosine, because this component of t2, this is with angle, so this one has to be t2 cosine of theta 2. And we have two components, so that's the reason we have multiply with 2. Or simply if you wanna write down in detail, so you can say we have t1 cosine of theta 1 plus we have t1 cosine of theta 1. So in this case, these two vertical components are acting vertically downwards, and this component is acting to the right, and this is to the left. So these two horizontal components, they will cancel each other. But we are only interested with vertical. So now in this case, we need to understand theta 1 and theta 2. Theta 1 is greater in this case than theta 2. So we have to compare in this case. If angle increase, so cosine of theta 1 has to be smaller than cosine of theta 2, because cosine is maximum when theta is 0. If theta increase, cosine of that angle decreases. So we can say in this case cosine of theta 1, this is smaller than cosine of theta 2. So now we have to compare tension. But before we compare tension, we need to consider R1 and R2. R1 has to be equal to R2, so simply I can write on here. This one has to be equal to R2 because the same picture and same force of gravity that is acting vertically downward. So in this case, R1 is equal to R2. If R1 is equal to R2, R1 is equal to R2, so we can write down 2t 1 cosine of theta 1. This one has to be equal to 2t2 cosine of theta 2. If cosine of theta 1 is smaller than cosine of theta 2, so it simply means that t1 has to be, means this one decrease. If this decrease, this part decrease, this one has to increase. So t1 has to be greater than t2. T1 has to be greater than T2, and R1 is equal to R2. Why? Because the same picture is hanging. So the force of gravity acting on this picture is the same. So the answer for this question has to be B. Question number 13 says an object shaped as a hemisphere rests with its flat surface on a table. The object has radius small r and density of the object is rho. The volume of a sphere is given to us, that is equal to 4 by 3 pi r cube. Which average pressure does the object exert on the table? So first of all, we need to understand, in this case, this is a hemisphere. Hemisphere means that this is half of sphere. So this will be the complete sphere. So the complete sphere will be somewhat like this. And in this question, only half of the sphere is given. And the radius of the sphere in this case is given to us, that is equal to r. That is r. So we need to find out P. P simply is equal to force exerted on the table over the contact area. And force exerted on the table in this case is equal to weight of hemispheres. So weight of hemisphere divided by area in contact with the table. Area in contact with the table is equal to area of this circle, means A will be equal to pi r square. So this is the area of circle. And mass will be equal to density of the sphere times volume times g. And in this case, volume of the sphere is given to us, that is equal to 4 by 3 pi r cube. But this is hemisphere, so we have to multiply this one by 1 by 2. So this is the volume of hemisphere, multiply by g, and this is divided by pi r square. So we can rewrite this one. So this is rho, we have 4 pi r cube times we have g, and this is divided by 3 times 2 times pi r square. Now just need to simplify. So in this case, we can cancel this pi with this pi, and we can cancel this 2 with 4, so we will get 2 here. And r square we can cancel with this, so we simply left with rho and here we have this is 2, and we left with R, and we have G here, and this is divided by 3. So if we simplify this one, simply we can say this is 2 by 3 rho R G. This is rho R G. So the final answer for this question has to be D. So this is the answer. Simply this is the main concept you need to understand. So this one is main concept. Question number 14 says a probe is used to monitor the quality of the water in the sea. The probe is suspended by a vertical string which is attached to a sphere. The stationary sphere floats in equilibrium on the surface of the sea as shown in the figure. The sphere has a weight of 5 newtons. The probe and the string have combined weight of 2 newtons. The density of seawater is equal to 1.03 times 10 to 3 kgs per cubic meter. The upthrust on the probe and thread is negligible. What is the volume of the sphere below the surface of the sea? Means we have to find out volume of the sphere below the surface. Mean this volume of the sphere we have to find out in this case. But in this case it is given to us that upthrust on the probe means on this probe and string is negligible. So in this case simply we need to understand this sphere is in equilibrium. It means the force is acting on the sphere upward. The force means we can draw the free body diagram. The force acting on the sphere upwards, this force will be upthrust. So this force is simply upthrust, and upthrust in this case has to be equal to the forces acting vertically downwards. So in this case we have two forces acting vertically downwards. One is weight of the sphere, that is equal to 5 newtons, and we have the weight of the probe and weight of the string, and the combined weight is equal to 2 newtons. So 2 newton is acting down. So in this case simply we can write down upthrust, that is equal to upthrust is equal to 7 newtons, and upthrust is equal to weight of fluid displaced. So very important one, weight of fluid displaced. So we can simply say is equal to weight of fluid displaced. So you need to understand the concept, not just use the formula without understanding the concept. So weight of fluid displaced in this case is equal to 7 newton, and weight of fluid displaced is equal to the density of the fluid displaced times volume of the fluid displaced, times G, and this one has to be equal to 7 newtons. And in this case volume of fluid displaced, this is equal to volume of sphere below the surface is equal to volume of sphere below surface, or we can say volume of fluid submerged in seawater. Volume of sphere we can say below surface. So this is below surface. Now simply we can use the formula. So we can simply use the formula here. So we can say this is Vs. So this is volume of sphere below surface. So we need to find out Vs. So Vs in this case simply will be equal to 7 divided by density of the fluid. So we can rewrite density of the seawater times G. So we have value of density of seawater, that is 1.03 times 10 to 3 multiply by value of G, that is equal to 9.81. Now if we solve this one, our answer should be equal to 6.93 times 10 to minus 4 cubic meters. So this is the volume of sphere below the surface of sea water. So this is how you can figure out. So the answer for this question is D. So D is the right answer. Question number 15 says, what is the center of gravity of an object? So first of all, let's try to understand what is center of gravity of an object. Center of gravity of an object is the point where whole weight of the body may be considered to act. And if we apply upward force, single upward force at that point, that is equal to weight of the object. So we can balance that object. Let's say we have this object. So where is center of gravity of this object? So center of gravity of this object simply you can find out by sliding this finger under this one. So at one point you will see, if you place your finger, you can balance this one. So simply you can see in in this case I can balance this one at this point. So at this point I'm applying just single force, and that single force is equal in magnitude but opposite to the weight of this pen, so I can balance that. So this point is the center of gravity, where whole weight of the body may be considered to act. So this is center of gravity. If the object is horizontal, center of gravity and center of mass, they lie at the same point. If object is vertical like this, center of gravity and center of mass, they will not be exactly at the same point. It depends on height of the object. If taller the object, the difference between location of center of gravity and center of mass will be greater. If shorter, difference will be smaller. So for this question, simply we need to find out center of gravity. What is center of gravity? Geometric center of the object? No, this is not true. The point at which the weight of the object may be considered to act. Yes, this is correct. The point on the object about which there is a zero net torque on the object. Center of gravity also can be out of the object, so this is also incorrect. The point where gravity acts on the object? No, gravity acts on the object everywhere. For example, if I look at this point, gravity is acting here. Everywhere there is a force of gravity, so this is also incorrect. So the answer is B. Question number 16 says a system with an efficiency of 74% wastes 230 watts of power. What is the useful output power of the system? Efficiency of the system is given to us, that is equal to 74%. It simply means that wasted output power, we can simply write down wasted P out. Wasted P out, this is equal to 26%. 26% means 26 by 100 times P in. So this is P in. In this case, we have wasted P out, that is equal to 230 watts. So simply we can multiply 0.26 with Pn. So when we have value of P in, then we can calculate useful output power. So P in from here, P input we can calculate, that will be equal to 230 divided by 0.26, and this will be equal to 884.6 watts. Now we need to calculate, in this case, useful P out. So we have P in. P in has to be equal to P wasted plus P output, means P useful output, P useful. So this is the output, this is the input. So we have in this case 884.6, and P wasted we have 230, and P useful means useful output power. This one will be equal to about 650. So this will be equal to about 650 watts. So this is our final answer. And so the answer for this question is C. So this is how you can figure out. Question number 17 says a projectile of mass 0.25 kgs is at a height of 30 meters above horizontal ground and traveling at a speed of 15 meters per second. A short time later, it is at a height of 35 meters above the horizontal ground and traveling at a speed of 5 meters per second. How much work is done against a resistance during this time? So simple way to answer this question is we can draw the projectile motion. So this is the projectile motion. So this is how this projectile is moving. So in this case, we can take any 2 points because we don't have a lot of information about this. So we can take any 2 points. So we can take 1 point here. Let's say when projectile is here, this is point A, and then after a short period of time, projectile is here at point B. When it is at point A, the height of this one is given, that is 30 meters, and the speed is given to us. So we can simply use conservation of energy in this case. Initial energy, this one has to be equal to the final energy. So the initial energy in this case, we have kinetic energy, we can say this is 1/2 m u square plus we can say mg delta h a. This one has to be equal to 1/2, so we can also write down a here. So this has to be equal to 1/2 mv we can say P square plus mg delta hp, b delta hp, so ground is our reference point in this case, plus work done against resistive forces, and this work done we have to calculate. So we can write down work done against resistive forces in this case will be equal to initial energy, or simply we can say this is 1/2 mu square plus we have mg delta ha, means height above horizontal ground when it is at point A, minus we have this is 1/2 m vb square minus we have mg delta hp. Now simply we need to plug in values and we can find out value of work done against resistive forces. So we have 1/2, so we have m, that is equal to 0.25 times we have speed at point A 15, so we have speed, this is 15 square, and we have plus GPE, that is equal to 0.25 times the mass times the value of G, that is 9.81, times height, that is 30 meters, and we need to subtract 1/2 0.25 times we have the speed at point B, that is 5, so this is 5 square, minus we have height, that is 0.25, means GPE at point B times 9.81 times we have the height, this is 35. If we solve this one, our answer has to be equal to 13 joules up to 2 SF. So this is the final answer. So the final answer for this question is B. So B is the right answer, and this is the work done against resistive forces. Question number 18 says a spring has an unstretched length of 4.50 centimeters. The spring is fixed at one end and a force of 35 newtons is applied to the other end so that the spring extends. The spring obeys Hooke's law and has a spring constant of 420 newtons per meter. We need to find out what is the strain of the extended spring. So first of all, we can sketch so you can see the picture. So we have unstretched spring, so this is unstretched spring, and the length of this spring is given to us, that is L naught. We can say L naught is equal to 4.50 centimeters. This is given in the question. Now we apply force on this spring, and the force we applied on this spring, that force is equal to 35 newtons, so that is equal to 35 newtons. So we can find out new value of L. We can say this is L new. So if we have value of L new, then we can subtract this one, we can find out, but we no need to find value of L new. We can simply find out delta L, because delta L will be equal to force applied on the spring divided by spring constant, means divided by K. So in this case we have F, that is equal to 35 newtons, and this is divided by K. K is equal to 420 newtons per meter. If we simplify this one, we will get delta L is equal to 0.03 meters. So this is value of delta L. Now we have delta L, we need to find out strain, and strain is equal to delta L by L. Delta L is equal to 0.083 and L is equal to 4.50 centimeters, so it means this is equal to 0.050 meters. And if we solve this, in this case our answer will be equal to 1.83. so the value of the strain in this case is equal to 1.85 we will get. If we solve this one, we will get 1.85, so this will be 1.85. If we solve, our answer will be 1.85. 5. So the answer for this question is C. So this is how you can approach this problem. Question number 19 says a wire is fixed at one end and extended by a force that is applied to the other end. The force is slowly increased from 0 and then slowly decreased back to 0. The force extension graph for the wire is shown in this figure. The graph line for the wire being loaded is the same as the graph line for the wire being unloaded. This statement describes the deformation of the wire. So first of all, let me explain you with a simple example. Imagine that if I place my finger on my cheek, you will see my cheek has deformed. Now if I remove the finger, you will see it has regained shape. So it means that this kind of deformation is elastic because my cheek has regained shape, or simply you can say it has returned back to its original shape and size. So this is elastic deformation, and same is happening in this case with the wire, because you can see in this case the final extension after unloading, final extension is equal to 0. So it simply means that this is elastic deformation. We can also understand this one in a little bit different way. Imagine that this is the wire. First of all, we extend this wire up to this point, and then we remove the force, and this wire come back to the original shape and size. So this kind of deformation is elastic. So simply you can imagine you extend the wire, and then when you remove force, slowly force come back to the same shape and size. So that kind of deformation is elastic. So it simply means this is elastic deformation. So the answer for this question has to be B. So the answer for this one is B. If it was plastic deformation, then maybe the graph will look like this. So when you will remove the load, maybe it will end up here, this curve. So in this case, you will see this part, it has extension, means the final length is longer than the original. So it has certain extension. So there is extension. So this will be plastic deformation. So the answer for this question is B. Until now, we have discussed first 19 questions, and I'll be uploading solution of the remaining questions by today or by tomorrow. So I'll see you next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1 variant 2. In the last two video, we have discussed from question 1 to question 19, and this video we will start from question 20 and we will discuss until question 29. Mean we will cover all the questions on waves from this paper, and in the next video we will discuss about electricity and radioactivity. As always we do, we will discuss these questions in detail so you can improve your conceptual understanding of AS physics, and also you can have better understanding of these questions. Let's study together, let's improve together. Question number 20 says, in a progressive water wave, two particles P and Q on the surface of the water are a fixed horizontal distance apart. P and Q oscillate vertically. At time t is equal to 0, the wave is as shown in this figure. Which graph best represents the variation with time of the phase difference between the oscillations of the water particle P and the oscillation of the water particle Q? So very nice question. For this one, you need to understand, if we take any two particles, let's say we take particle here and we take one particle at this point. So simply we can say this particle is R. So the phase difference between these two particles is 180 degrees. So we can write down here the phase difference between P and R. This is equal to 180 degrees. And these two particles, they have the same frequency and same time period. So the phase difference between these particles with time will not change. So the phase difference between these two particles will always stay 180 degrees. So phase difference simply does not change with time. So if you look at A, it is not possible answer, so this is incorrect because this is telling you phase difference is changing with time, and this is also telling you phase difference is changing with time, so this is also not possible. This is also telling you phase difference is changing with time, so this is also incorrect. So the correct answer for this one is D, because phase difference between two particles does not change with time. Phase difference remain same. So simply you need to understand phase difference between two particles remains same. Phase difference remains same because they have same time period and same frequency. So the answer for this question is D. Let's try to understand this one with the help of animation. As you can see, in this case we have four particles, so we can say this is particle 1, this is particle 2. So if you look at particle 1 and particle 2, so simply I can draw the line here. You can see these two particles always they have the same phase difference. Now if you look at next particles, for example, we can take this particle, we can also draw the line here. So if you look at this particle and this particle, they are 180 degrees out of phase, and the phase difference does not change with time. So the phase difference between any two particles remains same with time. So that's the point you need to understand. Question number 21 says, which statement about longitudinal waves and transverse waves is not correct? Longitudinal waves and transverse waves. For option A, it is given to us both waves can be polarized, but longitudinal waves cannot be polarized because they oscillate only in one direction. So this statement is incorrect. So the answer for this question has to be A. But if you look at option B, it is given to us both waves can form stationary waves. This is true. Longitudinal waves and transverse waves, they can form stationary waves. If we go to option C, it is given to us both waves can transfer energy as progressive waves. Yes, both waves are progressive waves because they can transfer energy. If you look at option D, it is given to us both waves obey the equation V is equal to F lambda. This is also true. So this option is also correct. So the answer for this question is A. Question number 22 says, an observer hears a sound wave emitted from a moving source. The observed frequency is less than frequency of the sound emitted from the source. What could be the reason for this? So in this case, observed frequency, this one is lower than frequency of the sound produced by source. It simply means that in this case, source is moving away. Source is moving away. Source is moving away. So this is the point you need to understand. If observed frequency is lower than frequency produced by the source, it means source is moving away if observer is at rest. So in this case, we assume that observer is at rest, and observed frequency, you can simply calculate speed of the wave divided by speed of the wave plus speed of the source, speed of moving source, time frequency of the sound produced by source if the source is moving away. So in this case, frequency is lower. It simply means that source is moving away from stationary observer. If you look at option A, it is given to us the source is moving away from the observer. Yes, this is correct. If you look at option B, source is moving towards, this is wrong. The speed of the sound wave in air decreases due to the movement of the source. No, speed of wave depends on the medium and it depends on type of wave. So we can simply say speed, it depends on medium. So if the medium is the same, it means speed will not change. And in different medium, speed of different waves is different because speed also depends on type of wave. So if medium is the same, it means speed will not change. So this one is wrong. The speed of the sound wave in air increases. This is also wrong because if medium is the same, speed remains constant. So this is also wrong. So the answer for this question is A. Question number 23 says, what is the approximate range of frequencies of electromagnetic radiation visible to the human eye? Visible to the human eye means the visible light. Only visible part of the spectrum of EM radiation we can see. Means only visible part of the spectrum our eyes can see. So in this case, simply we need to find out approximate range of frequencies of visible light. But we have approximate range of wavelength of visible light. So we can write down visible light and we can write down approximate range of wavelengths. Wavelength of visible light is about 400 nanometer to 700 nanometers. So this is approximate range of wavelengths. Now we need to convert this wavelength into frequency. Frequency simply is equal to speed of wave in air or in vacuum divided by lambda. So we have lambda. So this is also the wavelength of visible light in air or in vacuum. So we have to take the speed of light in air or vacuum as well. So speed of light in air or vacuum is 3 times 10 to 8, and here we have 400 nanometers, 400 times 10 to negative 9. Now we can simplify this. We can say this is 3 times 10 to 8. 400 we can say this is 4 times 10 to 2 times 10 to negative 7. If we 10 to negative 9, so if we further simplify, we can say this is 3 times 10 to 8 divided by 4 times 10 to negative 7. So here we can write down this is 3 by 4 times 10 to 8 plus 7. So if we simplify this one, 3 divided by 4, we get 0.75. We will get, and here we will get 10 to the power of 15. And if we further simplify, we can say this is 0.75 times 10 to 3 times 10 to 12. So this one we can write down 750 times 10 to 12. So this is equal to 750 terahertz. So this is the frequency. So if you look at given options, so we have kilohertz, this is incorrect, mega incorrect, giga, this is incorrect. So this is tera, means 10 to 12. So this is the possible approximate range. So the answer for this question is D. Question number 24 says a beam of vertically polarized light is incident normally on a polarizing filter. The filter can be rotated so that it is always in a plane perpendicular to the beam. The transmission axis of the filter is initially vertical. The filter is first rotated clockwise by an angle of 30 degrees so that the transmitted light waves have intensity I30. The filter is then rotated clockwise by a further angle of 30 degrees. What is the new intensity of the transmitted light wave? So for this question, first of all, we need to understand vertically polarized, beam of vertically polarized light wave. So means the light is vertically polarized. So this incident light, this is vertically polarized. So simply we can draw this one here. So this is telling us that incident light is already vertically polarized, and initially transmission axis of polarizing filter is also vertical. So in that case, all the light will just pass through this one. Then we rotate this angle by 30 degrees. So then it is given to us that's rotated by 30 degrees. So when we rotate filter by 30 degrees, the intensity of transmitted light is I30. So simply we can say I30, this is equal to I naught. We can say this light has intensity I naught, and this one will be equal to I naught cosine square of 30 degree. I mean cosine of 30 square of this value. We can also write down for better understanding, we can say this is cosine of 30 degrees. So we can write down this is cosine of 30 degrees, then you have to take square of this quantity, and then it is given to us the filter is rotated further by an angle of 30 degrees. So now the filter is at an angle of, we can draw here further 30 degrees. So we can say this is rotated by an angle of 30 degrees. So further angle of 30 degrees. So we can place this one here. Now in this case, angle with vertical, this angle is 60 degrees. So this is the second case. So we can write down in this case I 60 degrees. This one will be equal to I naught cosine of 60 square. So this is cosine of 60 square. We need to find out the new intensity of the transmitted light waves. Means this one we have to find out. So simply in this case we can say I 60. So let me also use here 60 degrees. This one is 30 degrees. So I 60 degrees divided by I 30 degrees, or simply we can say I 60 and I 30. So simply you can say, so it's easy to write down. So here we have, this is I naught, we have cosine of 60 square divided by, we have I naught cosine of 30 degrees square. I naught in this case will be cancelled with I naught. So here we will get, if you take square of this one, you will get this is 0.25 and this is divided by 0.75, and if we solve this one we will get this is 0.33. So in this case I 60, this is what we need to find out. So I 60 will be equal to 0.33 times I 30. So the final answer for this one is this one. So the answer for this question is B. So you need to understand we are using the same filter. First of all, the filter is just vertical. Then we rotate this one by 30 degrees. And again we rotate by 30 degrees for the second time. So the second time angle between vertical and transmission axis is 60 degrees, before it was 30 degrees. So that's the reason we have to use two times. First of all for angle of 30 degrees, then for angle of 60 degrees, then simply you can solve to calculate I transmitted when the angle between transmission axis and vertical is 60 degrees. So the answer for this question is B. I hope this one is clear to you. If you have any questions about this one, please leave your questions in comments. Question number 25 says a musical instrument is made using a long tube with a mouthpiece at one end. The other end is open and flared as shown in the figure. A musician maintains stationary sound waves with a node at the mouthpiece and an antinode at the other end. The lowest frequency of sound that the instrument can produce is 92 Hz. We need to find out which different frequencies of sound can be produced by the instrument. So in this case it is given to us that there is a node at mouthpiece. Mean always at this point we have a node, and at this end always we have an antinode. So this pipe is just one end closed pipe. One end open pipe you can say, or you can say one end closed pipe. One end closed pipe. And in one end closed pipe only odd harmonics are produced. Only odd harmonics are produced. So this point is very important. Only odd harmonics are produced. So this is the main point you need to answer this problem. And this question is a repeated question. You will also see this one in other past papers. Only odd harmonics are produced. It simply means that there will be frequency F1, fundamental frequency. Then next frequency will be 3 times of F1, and next frequency will be 5 times of F1. Next one will be 7 times of F1, and so on. So fundamental frequency is given to us, that is equal to 92. So the next frequency means F2, you can say next frequency. This one has to be equal to 3 times of F1, means 3 times 92, and this one will be equal to 276 Hertz. And next frequency of next maxima, this will be equal to 5 times of F1, mean 5 times 92, and this will be equal to 460 Hertz, and so on. So the answer for this question cannot be A because this is not correct, cannot be B, this is incorrect. It can be C because we have 92, we have 276, 460 hertz, and this is also not possible because this is also incorrect. So the answer for this question is C. And this question is very important one. You need to understand, if it is one end closed pipe or one end open pipe, only odd harmonics are produced. So this is first maximum frequency, and this is the second one and third one, and so on. Only odd harmonics. F1 is representing the frequency when we will hear the first loudest sound, and second, we can simply say we will hear the first loudest sound when the frequency is equal to 92 hertz, and we will hear the second loudest sound when the frequency is equal to 276 hertz, and we will hear the third loudest sound, or you can say third maximum, when frequency is equal to 460 hertz, and fourth one when the frequency is equal to this one. So this is third maximum, means third loudest sound. When the stationary wave is formed inside this pipe, we will hear the third loudest sound, and that time frequency has to be equal to this one. And between these two, for example between second and third, there will be no stationary wave formed because resonance will not take place. So resonance is only taking place at these certain frequencies, and we call them, these are resonant frequencies of this particular pipe. So this point you need to understand what these frequencies are representing. In case of tuning fork, for example, let's say we have a pipe and we have one tuning fork here. So when we place this tuning fork here, we strike this one with rubber pad, and we place at the top of this pipe. If the frequency of this one is 92, we will hear the first loud sound. Then we change this tuning fork and we use an other tuning fork. So the next tuning fork must have these frequencies, and if the frequency of the next tuning fork is equal to this one, again we will hear the loudest sound. And then again, if we change this tuning fork and we use a tuning fork which has frequency that is equal to 460 hertz, again resonance will take place and stationary wave will be formed inside this pipe, and we will hear the loudest sound. Question number 26 says two waves of equal frequency and amplitude are traveling in opposite directions along a stretched string. When they meet, they form a stationary wave with 3 nodes and 2 antinodes. The frequency of both waves is doubled and a new stationary wave is formed. How many antinodes are there in the new stationary wave? So first of all, we can draw first stationary wave. First stationary wave has 3 nodes, so we can draw these dots here to represent nodes. 3 nodes we have and 2 antinodes, so here we can draw. So we have antinode here and we will have antinode here. So 2 antinodes and we have 3 nodes. So we can draw over stationary wave. So stationary wave will look like this. We can also draw the dotted line here to represent stationary wave. So this is how stationary wave will look like. For the second case, it is given to us the frequency is double, but wave is the same, type of wave is the same, medium is the same, so means speed will not change. If frequency is double, wavelength has to be half, means this become half. So we can draw 2 nodes here. Now we have 5 nodes, so we can redraw here. We have 5 nodes, so we have 5 nodes. So how many antinodes? We can draw first of all this stationary wave. So stationary wave will look like this. We can also use dotted lines to make these loops. So this is new stationary wave, not very good looking, but at least you can get the idea to count number of antinodes. So let me little bit redraw this part. This is not good looking, and also this part, this is not very good looking. So I can draw this node here and let me use same color. So we have here this one, and here we have this. This is bit better. So in this case, we have one antinode here. So this is one antinode, this is another antinode, and here we have another antinode, and here we will have an other antinode. So we have 4 antinodes in new waves. So the answer for this question has to be D. Question number 27 says a transmitting mass sends out microwaves of wavelength 1.5 centimeters and radio waves of wavelength 1.5 kilometers. A receiving area behind a mountain can detect the radio waves but not the microwaves. What is the reason for this? So in this case, when this mass is sending microwaves, the wavelength is very small. So these waves, they just go straight. They will not diffract by a mountain. So when this will send radio waves, these radio waves, they will diffract and they will reach behind the mountain and they will reach the receiving area. So this is the point you need to understand. So the height of the mountain will be in height of mountain. In a different way, we can also understand height of the mountain, this will be in kilometers, 1 kilometer, 2, 3, 4, it depends. And lambda of radio waves, this is comparable with height of the mountain. So in this case, there will be significant diffraction comparable with height of mountain. So in this case, there will be significant diffraction. So due to diffraction, receiver can receive radio waves, but receiver cannot receive microwaves. Significant diffraction, because in case of microwaves, diffraction is very little. So waves will not diffract, so they will just travel in a straight line. So that's the main reason. Now if you look at given options, it is given to us the radio waves are coherent but microwaves are not coherent. That doesn't matter. Coherent means phase difference is the same. So this option is incorrect. The radio waves are diffracted around the mountain but the microwaves are not, because the wavelength is very small as compared with the size of the mountain. So this option is correct. The radio waves are reflected by the mountain but the microwaves are not. So this is not true. Reflection doesn't depend on wavelength. The radio waves travel at the speed of light but the microwaves do not. Radio wave and microwaves, they have the same speed because they are electromagnetic waves, same type of wave and in the same medium, so their speed has to be the same. The radio waves travel at the speed of light, so this is also incorrect. The speed is the same in the medium. So the answer for this question is B. Is the typical question. You will see this question in other past papers as well. So this is repeated. Question number 28 says waves are emitted from 2 coherent sources. Which statement about the waves must be correct? So first thing we need to understand, when we say waves are coherent, it means that they have the same frequency and also they have constant phase difference. So they have constant phase difference. So these 2 points you need to understand about coherent waves. They have constant phase difference. They are in phase? No, they should have constant phase difference. They are transverse waves. They also can be longitudinal waves. So longitudinal waves also can be coherent waves. So this is also incorrect. They have a constant phase difference? Yes, this is correct. They have a same amplitude. Amplitude is not required to be the same. So this is also incorrect. So the answer for this question is C. So these 2 points you need to understand about coherent waves. Amplitude is not required to be the same, and also for 2 waves to be coherent, they don't need to be in phase, but they must have constant phase difference. So they should have the same frequency as well. Question number 29 says the diagram shows a screen that is a distance capital L from a diffraction grating. The grating has a total number of capital N lines. Any 2 adjacent lines are a distance small d apart from each other. A beam of parallel light of wavelength lambda is incident normally on the grating. which quantities affect the distance between the first order diffraction maxima on the screen. Mean how this distance is affected, how this distance is affected. So this distance, or simply we can take half of this one. This is distance from the center maxima, or and also distance between center maxima and between first order maxima. Mean how this distance is affected. For this distance, we need to understand that d sine of theta, this is equal to n times lambda. So in this case, we are talking about first order maxima. It means n is equal to 1. And this distance is depending on this angle, theta. So theta in this case will be equal to sine inverse lambda over d. N is equal to 1, so simply if you want to write down, you can say this is 1. So it means that distance is depending on lambda and also is depending on d, but distance is not depending on n. For example, if we have diffraction grating, this has these slits. So let's say this diffraction grating has number of slits. So we have 1, 2 and 3 slits. And we have another diffraction grating. Let's say that diffraction grating has more number of slits. So we can say more number of slits. So in this case, we have 1 slit, 2, 3, 4 and 5. As long as the distance between the slits, this distance is the same. So if this distance between the slits is the same, value of theta will not be affected as long as d is the same, because theta is depending on d, theta is not depending on n. So it is independent of n. And so we can say it does not depend on number of slits, or we can say number of lines. So it does not depend on number of lines. And one factor more that is not in this equation we need to understand. Now if we move this screen, for example, if we place screen here at this point, and if we place screen here, so you can see how this distance will be affected. So I will draw line here. In this case, I will be extending this line. So I will extend this line so you can see the difference, and also I will extend this line so you can see the difference. And let me use different color, and also let me make this one a little bit thicker here. So in this case, now simply you can see, if I move this screen to this point, let's say we move screen to A position, and this is B, and this one we can say this is position, let's say is C. If we move to A, you can see in this case this has decreased, but if we move this screen to B, you can see this distance, it has been increased, so it means that this is depending on L. So this is theta is also depending on L. I mean this distance is also depending on L. So the distance between the first order diffraction maxima also depends on L. So we can also write on here, it depends on L, because this distance is depending on L. L is the distance between diffraction grating and the screen. So it depends on where you place the screen. So it depends on D, yes. It depends on lambda, yes. It depends on L, yes. It depends on N, no. So the answer for this question has to be A. I hope this question is clear to you. I try to explain you in a beautiful and a simpler way so you can have clear understanding. Just leave your questions in comments and I will try to answer as soon as possible. And the solution of remaining questions on electricity and radioactivity I'll be uploading by tonight or by tomorrow morning. If this video was helpful and this video has helped you to improve your conceptual understanding, and also if this video has given you better understanding of these questions, then please like and subscribe the channel, because your encouragement is very important. See you in next video. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from March 2023, paper 1, variant 2. In the last 3 videos, we have discussed from question 1 to question 29. And this lesson, we will start from question 30 and we will discuss until question 40. Means we will discuss all the remaining questions from this paper in this video. And we will be talking about electricity and radioactivity, two important topics. At least 25% of this paper is from electricity and radioactivity. So understanding of these topics, these two topics, is very important. We will discuss these questions in detail as always we do, so you can improve your conceptual understanding of these topics and also you can have better understanding of these questions. Let's study together, let's improve together. Question number 30 says a wire carries a current of 0.10 microamps. The potential difference across the wire is 10 millivolts. How much energy is dissipated by the wire in a time of 10 seconds? So first of all, we can just imagine wire as a resistor. So this is the wire. It has certain resistance and current passing through this wire is given to us I is current. That is equal to 0.10 times 10 to minus 6 amps. And if we connect voltmeter across this wire, the reading on this voltmeter is given to us, that is equal to 10 millivolts. Mean PD across this wire is equal to 10 millivolts. And if current passed through this wire for a time of 10 seconds, how much energy will be dissipated? Mean how much electrical energy will be converted into thermal energy? So that is what we need to calculate. So simply we can start with E dissipated. E dissipated, energy dissipated. So this is I. Energy dissipated simply will be equal to VI times T. Now simply you need to plug in values. Value of V is 10 millivolts. So this is 10 times 10 to minus 3 volts. We have to use SI base units. And value of current is given, that is equal to 0.10 times 10 to minus 6. And we have value of time, that is equal to 10 seconds. Now if we simplify this one, we can simply say this is 10 times 10 times we have 0.10, so we can replace 0.10. So we can replace this one with 0.10 means this is 10 divided by 100 and the powers we have 10 to minus 3, 10 to minus 6, it means this is 10 to minus 9. Now we can simplify it, so this 100 we can cancel with this, so we're simply left with 10 times 10 to minus 9 joules, and this is equal to 10 nanojoules. Because 10 to minus 9, this is nano, so this one is nano. So the answer for this question has to be D. Question number 31 says, what is the definition of the potential difference across an electrical component? Potential difference. Potential difference simply is equal to amount of electrical energy converted into other forms of energy, electrical to other forms of energy per unit charge. To other forms of energy per unit charge. So this is how we define potential difference. Or in simple language, you can also say that PD is equal to amount of work done per unit charge. Work done per unit charge. So this is another way to say PD is equal to work done per unit charge. Now if you look at given options, it is given to us. For option A, it is given to us energy transfer per unit charge. So this one seems correct because amount of electrical energy converted into other forms of energy per unit charge, that is the PD. So this seems correct. But if you look at next one, it's telling you energy transfer per unit current, this is wrong. Energy transfer per unit resistance, this is wrong. Energy transfer per unit time, this is wrong. This is the energy transfer per unit charge. So the answer for this question is A. Question 32 says, which graph represents the way the current I through a filament lamp varies with the PD across it? Filament lamp. For filament lamp, first thing you need to understand is that as temperature of the filament lamp increases, resistance of filament lamp increases, and temperature of filament lamp increases when more electrical energy is converted into thermal energy. Means more electrical energy is converted into thermal energy. More electrical energy converted into thermal energy means the PD across filament lamp increases into thermal energy, or simply we can say temperature will increase when the PD across filament lamp will increase. So when PD across filament lamp increase, it means more electrical energy per unit charge has been converted into thermal energy. So the temperature of the filament lamp will increase and resistance of the filament lamp also will increase. So if you look at these graphs, we have in this case I against V. So we can write down the gradient. Gradient of I versus V graph is equal to 1 over R, because R is equal to V over I, and 1 over R, this is equal to I over V. So in this case, gradient is representing 1 over R. So this is the important point you need to understand. So gradient in this case, let me rewrite here. Gradient is equal to 1 over R. So it simply means that if the gradient is increasing, it means resistance is decreasing, and vice versa is also true. If you look at first one, gradient is increasing, so it simply means that resistance is decreasing. If you look at this one, gradient is decreasing, so it means that resistance is increasing. For this one, gradient is constant, it means resistance is constant. And for this one, gradient is increasing, it means that resistance is decreasing. For filament lamp, resistance increases with PD, so it means the answer for this question is B. But one point you need to understand is that when we calculate the resistance from IV graph, we have to draw secant line. So if I draw the secant line, for example, from this point, I can connect here. So you have to look at the gradient of the secant line. That is a proper way. So if I connect here, you can see gradient in this case is increasing, so it means that resistance is decreasing in this case. And also you can do for this one. So if I draw the secant line from this point and then I draw secant line from this point, so you can see the gradient of the secant line is decreasing, so it means resistance is increasing. So the answer for this question is B. Question 33 says the table shows the properties of two different wires P and Q. Wire P has a cross section of diameter small d. What is the diameter of the cross section of wire Q? So we have two wires. So first of all, for wire P, simply we can write down, for wire P we can write down resistance. This is equal to rho L divided by pi by 4 d square. I mean, this is the cross sectional area divided by cross sectional area. Now for wire Q, we can rewrite this equation. For wire Q, it is given to us that resistance is equal to R by 4, resistance of wire Q, and this is equal to rho by 3 times we have L, that is equal to 2L divided by cross sectional area. Pi by 4, we can say diameter is x, so we can write down this is x square. Now simply we can replace R with this quantity. So R we can write down, this is equal to rho L by pi by 4 d square times we have 1 by 4, means we have here 4, so 4 we have here, so this 4 is coming here, and this is equal to rho by 3 times we have 2L. Simply we are just replacing this R with this value divided by, we have this is pi by 4 times x square. Now simply we need to cancel. So in this case we can cancel this 4 with this, we can cancel this pi with this pi, we can cancel this rho with this rho, we can cancel this L with this L. Now we simply left with d square on this side, so we can write down this is 1 over d square, and here we have 2 by 3, and this is divided by x square divided by 4. Now simply we cross multiply. So if we cross multiply, in this case we will get x square divided by 4, and this is equal to 2 by 3 times d square. We need to find out x, so we can write down x square. This will be equal to 8 by 3 times d square. So from here we can find out x, that is equal to 8 by 3 root of this times d. So if we solve this one, we will get 1.6 d. So x is equal to 1.6 times of d. And so the answer for this question is B. So the main concept is that first of all write down R, and also write down value of R for Q. So we can say this is RQ. If you want to write down here, you can also say this is RP, and then just replace value of R with this value of R, mean replace with this one, and just simplify then, and you will get this answer. Question 34 says a cell has a constant electromotive force. A variable resistor is connected between the terminals of the cell. The resistance of the variable resistor is decreased. Which statement about the change of the cell's terminal potential difference is correct? So a typical type of question. So the best way to answer this question is you need to sketch the circuit. So we can sketch power supply. Power supply has certain internal resistance. So this is our cell with certain internal resistance, because in the question it is given to you a cell. So this is cell, it has internal resistance. So we can draw these dotted lines to represent cell. So this is the cell. So this is the positive terminal of the cell, and this side is negative terminal of the cell. And between terminals of this cell, variable resistor is connected. So we can also connect variable resistor. So this is variable resistor. In the question it is given to us that EMF is constant. EMF constant, and resistance of this variable resistor is decreased. So we need to understand, if we connect a voltmeter across this variable resistor, reading on this voltmeter will give us terminal potential difference across terminals of this power supply. So we can say in this case EMF, this has to be equal to terminal potential difference plus V lost. So we can say V lost. We can rewrite this one. We can make Vt the subject. So we can make Vt the subject because we have to explain the change in Vt, means the terminal potential difference. Terminal potential difference is equal to EMF minus Vt. Vt we can say this is I times R. So if we decrease the resistance, if we decrease this resistance, so current in the circuit it will increase. So current in the circuit will increase, but internal resistance will not change. So if current increase but internal resistance remain constant, so it simply means that V lost will increase. If V lost increase, then EMF is constant, so it means terminal potential difference will decrease by decreasing the resistance of variable resistor. So this is the point you need to understand. If this concept is clear to you, now we can find the answer. The terminal PD decrease, yes, that's true, because more work is done moving the unit charge through the internal resistance of the cell. So this option is correct. If you look at option B, it is given to us terminal PD is decreased. This is right, because the current in the variable resistor is decreased. Current in the variable resistor increased, so this is incorrect. The terminal PD increased, no. Terminal PD decreased. The terminal PD is increased, no. Terminal PD has decreased in this case. So the answer for this question is A. A very nice question and a typical type of question. So you need to understand how to deal with this type of problems. Question 35 says Kirchhoff's two laws for electric circuits can be derived by using conservation laws. On which conservation laws do Kirchhoff laws depend? So we need to understand Kirchhoff's first law. It is based on conservation of charge. Is based on conservation of charge, and the second law is based on conservation of energy. conservation of energy. So if you look at given options, this one is correct, but this is incorrect. If you look at option B, this is correct, this is also correct. So the answer for this question is B. C cannot be the answer. D also cannot be the answer. Question 36 says a battery of electromotive force 10 volts and internal resistance small r is connected to 3 resistor of resistance capital R 2.0 ohms and 15 ohms as shown in the figure. A current of 0.45 amps is in the resistor of resistance 2.0 ohms and a current of 0.48 amps is in the resistor of resistance 15 ohms. We need to find out what are the values of small r and capital R. So if you look at this given circuit, we can see here we have current and we have the resistance. So simply we can find out PD across this, and PD across this one is also the same as PD across this branch. So PD across these two branches is the same. We can calculate value of this V. V will be equal to I times capital R. So I we have in this case 0.48 amps and value of resistance is 15. Now if we multiply this one, we will get V is equal to 7.2 volts. So this is the PD across this. Now if we look at this battery and internal resistance, we can also say 10 volts. This one has to be equal to 7.2 plus PD across this one, mean the V lost in internal resistor, this V. So we can say this one is V lost. So V lost, from here we can find out V lost will be equal to 10 minus 7.2. It means this will be equal to 2.8 volts. So we have value of V lost as well. And also we can figure out from here current in this branch, means current entering the battery and leaving the battery has to be the same, means current here at this point and current entering the battery, it has to be the same. And this current has to be equal to this value 0.45 because this current is entering this junction and current entering from this branch is 0.48. So this is 0.48. So this current is passing through the battery and passing through this internal resistance. So now we can say in this case V lost, and this is equal to I times small r. So we can find out value of small r. This will be equal to 2.8 divided by, we have 0.45 plus we have 0.48. So if we solve this one up to 2SF, we will get R is equal to 3.0 ohm. So this is value of small r. Now we need to find out value of capital R. In order to calculate value of capital R, we can simply use PD across this branch. PD across this branch is equal to 7.2. So this is 7.2. And current passing through this resistor, we have that is equal to 0.45 times we have capital R plus we have this is 0.45 times we have 2. Now we need to find out value of capital R, value of capital R. So simply we can simplify 7.2 minus we have 2 times 0.45, then this is equal to capital R divided by 0.45. So if we solve this one for R is equal to 14 ohms. So this is final answer. So this is value of capital R. So the answer for this question has to be A, because internal resistance is 3 ohms and resistance of capital R, this is equal to 14. So the answer is A. Question 37 says a battery of negligible internal resistance is connected in series with a thermistor and a fixed resistor of resistance 12.0 kilo ohms as shown in the figure. The table shows the resistance of the thermistor at 2 different temperatures. The potential difference V out across the fixed resistor is 4.50 volts when the thermistor is at a temperature of 20.0 degrees Celsius. What is the V out when the thermistor is at a temperature of 50 degrees Celsius? So when the thermistor is at a temperature of 20 degrees Celsius, the resistance of thermistor is given, that is equal to 12.0 kilo ohms. Means at 20 degrees Celsius, the resistance of this thermistor is the same as resistance of fixed resistor. For this one is given to us that V out is equal to 4.5 volts. If resistance of this one is also equal to 12.0 kilo ohms, so it also means that PD across this one also has to be equal to 4.5 volts, because these are two identical resistors and they are connected in series. They have the same resistance, so they have the same current, so the PD also has to be the same. So V is equal to IR. If R is the same, I is the same in series, so V also has to be the same. So this is a smart way to answer this question. We can also use potential divider formula. We can do all those things, but this is a smart way because in your exam time is very important. So this is 4.5, this is 4.5. So this battery is 9.0 volts. Mean the PD across this battery, or simply you can say EMF of this battery is equal to 9.0 volts. So this is the first case. So we can clean this now and we can write down next case. For the second case, it is given to us at temperature of 50 degrees Celsius. At temperature of 50 degrees Celsius, resistance of thermistor is equal to 5 kilo ohms. So we can say this is 5.0 kilo ohms. And resistance of this fixed resistor, this is constant, this is 12 kilo ohms. Now we need to find out what is value of this V out. So this is simple potential divider circuit, so we need to find out V out. So the V out has to be equal to 12 divided by, mean the resistance of this resistor divided by total resistance of the circuit. Total resistance of the circuit is equal to 12 plus 5 kilo ohms. So we no need to write down kilo because that will be cancelled. If still you want to write down for better understanding, so you can also write down here, this is 10 to 3 kilo ohms multiply by EMF of the power supply, that is equal to 9.0 volts. Now if we simplify this one, in this case you can simply say this multiple will be cancelled. Now if we simplify this one, our final answer will be equal to 6.35 volts. So this is how you can calculate V out. This is a smart way to answer this problem, so you can save some time. So the answer for this question has to be C. Question 38 says, what is a conclusion from the alpha particle scattering experiment? From alpha particle scattering experiment, we concluded that most of the atom is empty space, or we can say mass is concentrated at the center of the atom. So mass is concentrated in the nucleus. So few things you need to understand. Most of the atom is empty space. Most of the atom is empty space, and we concluded that mass of the atom is concentrated in the nucleus. Mass of the atom is concentrated in the nucleus. So these points you need to understand about alpha scattering experiment. And nucleus is positively charged. We can also say nucleus is positively charged. Nucleus has positive charge. So these are the conclusions from alpha scattering experiment. Nucleus has positive charge. So we can say this is nucleus has positive charge. So these points we can conclude from alpha scattering experiment. Now if you look at given option, it is given to us protons and electrons have equal but opposite charges. This is not conclusion from alpha scattering experiment. Protons have a much larger mass than electrons. This is also not conclusion from alpha scattering experiment. The nucleus contains most of the mass of the atom. This is correct. The nucleus of an atom contains protons and neutrons. Neutrons actually were discovered later than this experiment, so this is also incorrect. Neutrons were discovered in 1932, around this time. So the answer for this question is C. Question 39 says americium-241 is a radioactive nuclide used in smoke detectors. It undergoes alpha decay to form nuclide X. This decay may be represented by the equation shown here. What are the values of A and Z? So it is given to us this is alpha decay. So it means atomic number of alpha is 2 and mass number of alpha is 4. So simply at this point z has to be equal to 95 minus 2. So we will get 93. Z is equal to 93, and A has to be equal to 241 minus 4. So we will get 237. So Z is 93, so this one is right. A is equal to 237, so this is also right. So the answer for this question is A. A is correct option, and rest of the options, these are incorrect. Question 40 says a top quark has a charge of plus 2 by 3e, where E is the elementary charge. We need to find out what is the charge on an anti-top quark. For top quark, it is given to us that charge on top quark is equal to plus 2 by 3e. So the charge on anti-top quark, it has to be opposite in sign but equal in magnitude. So anti-top quark, its charge has to be equal to minus 2 by 3e, because top quark, this is a particle. Particle and antiparticle, they have same magnitude of charge and opposite sign of charge. So this is antiparticle. So the answer for this question has to be A. So A is the answer. That's all for this paper. We have done all the questions from this paper. I hope this paper was helpful and you have improved your understanding of AS physics concepts, and also you have better understanding of these questions. If this video was helpful, please like and subscribe, because your encouragement is very important.